you put the stream in the chat?
Awesome.
Not yet.
Hey everybody, welcome to Orchestructure. I don't want to interrupt your food. You can eat while the presentation's going on. You can grab more, whatever you want to do. I believe bathrooms are just to the left, right outside the door. My name is Mario Loria. Welcome again to Llamasoft, who is a very gracious sponsor and has been supporting the meetup any way they can. He's putting signs up on the main doors. So, very cool. I won't talk very much right now. I just want to do a shout out to our sponsors, StockX, Llamasoft, Ithaca, and Fly.io, the application delivery platform. They have all been amazing. We're looking for more sponsors as well if anyone's interested. We don't require much money to be a sponsor. We just love the support, and we can use the money to help put these things on and do workshops and other activities. So today we have Curt from Heptio, who is going to be talking about Terraform, a little bit more advanced Terraform, I think. One last thing, I'm co-organizing DevOps Days Detroit, which is next week on Wednesday and Thursday. I highly advise you to get a ticket. They're going really, really fast. It's going to be a great event. We have people like Armin Dadgar from HashiCorp, John Willis, who worked at Docker Incorporated, and many other really great speakers that you'll want to hear from. People from PagerDuty and other associated both startups in the area and other major companies. So you'll definitely want to check it out. Ask me for details or any other information if you're interested. And with that, I think I'm done talking. Go ahead, Curt.
Okay. So here's Wi-Fi if anybody needs it. All right, so quick have this here. I threw this thing pretty quickly together. So I'm hoping there's enough content. There should be enough, but if you have any questions or I don't explain something, please let me know. I also do not have my speaker notes because stupid thing set that up properly, improperly. So I'm going to just go off my slides and remember what I wrote. All right, so I started using Terraform in April, but I have a lot of history around CloudFormation and infrastructure. Been doing this for 20 years now. So when I picked up Terraform, everything I found was efficient, I felt. So I'm hoping that I can give you some methods for using Terraform on a team. And probably a better title for this is Defensive Terraform. How do we survive like the way Terraform works and keep infrastructure resilient, reliable stuff. So, and then the subtitle, oh shit, how do we share the state file? It's something that everybody needs to learn when they encounter Terraform. So, yeah, my name is Curt Micol. I go by Essenchi literally everywhere on the internet. I've been every one of these titles at some point in my life. It's all the same job. Don't let anybody pay differently. So right now I work at Heptio, but previously I've worked at GitHub, engineer at Heroku. I just got out of Simple last year. So all this experience is leading into Terraform. So we'll see how it comes out. So who here has used Terraform or is familiar with it or has great experience with it? Okay, so we have most people here, but I'm going to kind of go through a kind of a primer. So my experience with Terraform previous to this was a couple of projects here and there. Like it's simple, we needed a Redshift cluster and we didn't want to go click in a console, so we quickly did Terraform. We actually managed all of our infrastructure with CloudFormation and this Python wrapper that was a nightmare. So coming into this, I just started reading lots of blog posts and trying to figure out how to use Terraform in a way that makes sense for both my experience, but also like I can share my work with other teams and encourage them to use Terraform as well, while making it easy to pick this up. So, I mean, it's a great tool, and HashiCorp has done a great job with it. So for those who haven't seen, I'm going to run through a quick explanation here. Generally, this would be 3 files. We have a variables.tf, a main.tf, and an outputs.tf. You can see the comments there. And this is what they call a module in Terraform. It's usually they're contained within a directory. The basic unit is a resource down there under the main.tf. A resource is some definition or some way of executing some idea. So here I'm going to create a random integer. This is the random provider. Terraform has lots of providers with lots of different resources. This is a basic one that comes with Terraform. And basically, it's just going to allow me to randomly produce an integer. This is useful if you want to have some variability in the name or some number that you don't care about necessarily, but you want it to be there. The top thing, the variables.tf, is kind of the input to our resource function, if you want to think about it that way. This we're going to default to 999 as our max. You can see we're using it in the resource there, var.max. That's just referencing that variable. And then the outputs, what our resource quote function is going to produce. And we can tell Terraform to spit it out for us. Otherwise, it just kind of does the work and keeps it for itself. So everything is explicit like this, which I think is really key feature of Terraform, is it requires explicitness. Implicit infrastructure is frightening, especially if you're an SRE. So you want to know everything that's going to happen. And basically, let me talk real quick about that output. That's important for us. So the value there is the random.integer. That's a resource dot our name test dot result. And every resource in Terraform, the documentation is fantastic, by the way. Every resource has a number of inputs or a number of configs, like the min and max there, and then has a whole list of attributes for outputs that you can get. And again, you really want to be explicit about using these things. So that's a very simple idea. Terraform builds on what I think is probably the most important thing to understand about computers, is that everything in a computer takes some input, it filters it in some way, and outputs it. Like, if you think of your infrastructure this way, your life will be so much easier. Terraform, like, buys into this idea and makes it so that if you really think about your input, your filters, and your outputs in this way, it's going to be a much easier ride. So if you're new to computers, if you're old at computers, this is the most important paradigm in computers for me. Like, I learned this at Heroku, and I realize it's simple, right? But there was a guy at Heroku who taught me that everything can be summed up in this simple function. And I think it's probably the most important lesson I've learned in computers. So Terraform, once you have your resource and your module, you do what's called a plan. And this is Terraform. It's kind of a dry run. Terraform's going to go through, look at its resources, and say, okay, I think this is what we're going to do. And here we can see it's going to create a random integer .test. There's some of its properties that it knows about going into it, and then it's telling you that it's going to compute these other variables. So the ID and the result there are going to be computed. And then at the end, it just gives you a little summary of what we're going to do. Now, in a larger resource, right, this is going to be a couple pages worth of text showing you, okay, we're going to create this instance, we're going to create this volume. It's going to do a lot of work. But it's a simple explanation, and it fits on the slide. So, so we plan for that. That's a dry run again. But then we apply it. And this is when Terraform actually does the work. So you can see it's running through. It shows you that it's going from nothing. This random integer.test had nothing previously in max, and now it has 999. Had nothing as a minimum configuration, now it has a 1. And the result is going to be computed. And you can see our very bottom here in the outputs, test underscore integer 691. That's what's been reported by that random integer resource. And I've said, spit it out for me. And I've named it test integer. I've kind of built this function to produce this output, right? Does that make sense for everybody so far? Pretty cool. I know we have a lot of people experience, but I want to make sure that it's clear. So obviously, that's a very simple resource. Where it gets really interesting is when we start creating dependencies. So here, I'm adding another resource called static that is going to take in as input the output of the previous random integer test as a seed variable to its resource. This is not really useful whatsoever. It just shows a dependency. So I'm not even going to explain why you would do this, because you never would do this. But it shows how we're using the output from one as a dependency in another. And so once we apply, our state file changes. Now, I didn't show the state file previously, but kind of hard to show. It's so huge. But here's what changes when we made that simple little change. So we had our first 3 files, our variables, our main, our output. We added that one resource to main, and we get this little diff, right? Our serial number has been incremented. That means our state file's moved ahead. And we now have our static resource in there. And see this little depends on. This is the dependency tree that Terraform builds. And this is why Terraform is really cool, because you can start building this giant dependency tree that you don't have to keep in your head. Although I'm going to explain why you want to keep some of it in your head in a minute. But all of this is stored as JSON in what they call the terraform.tf state file. By default, it ends up in the same directory where you run this at. There's arguments to plan and apply to point that somewhere else, which I highly recommend you do. But one thing before we get to the state file more, I want to talk about what Terraform does here. Is Terraform has two states, and it has you develop an intent. So you write out an intent in Terraform, like this is what I intend to happen, what I want to happen, and then Terraform works to realize it. And once it realizes it, it saves it in this state file. Before it's in that state file, it means nothing. It's just in your brain. It's what you've written down. Again, it's your intentions. It's not necessarily what Terraform can or will do. And I think, again, these are two really important states to realize when you're writing Terraform, that you can start out small, build up your intent, and keep adding until it realizes what you want. You don't have to do one or the other here. You can start small with your intentions. And that's why I kind of showed the initial resource and then the dependency. We build up where we want to be. And there's a reason for this, because when Terraform runs, it's hoping, we have those computed variables, right? It's hoping that it can compute those things. If it encounters an error, your intentions now are like mid-realized. They're not really formed yet. So remember these two things as we move forward. So back to the state file. We're now at a realized state, right? We have our resources are saved in this giant JSON blob. In every infrastructure, no matter what it is, whether Terraform databases, Kafka, Elasticsearch, good Lord, anytime you have to manage state, this is where your pain is, right? Everybody loves Amazon. You bring it up an instance, it goes away. You can do all these cool things. But as soon as you attach it to a database, holy shit, your life changes, right? Your life is now based around that state and how you manage it. So state is extremely painful, but the most important part, because if we didn't remember everything that we did on computers, well, we wouldn't be here. So Terraform has a pretty decent answer about managing state. And that's remote state management. So there's blog posts mention this, but no one really talks about this at the outset. This is the first thing you should do in Terraform. Having state in a local directory of where your intent is, where you write your Terraform, is a scary idea, especially if it's more than one person working on it. You can say, well, we have Git, but who's running plan and apply? How visible is that, right? And anytime someone runs apply, that state is changing. So if someone runs that and you don't know about it, and then you run it, everything's gone. You lost all confidence now in your realized Terraform, right? Because it's got an instance out. I'm gonna give you a scenario, right? There's an instance out there. I run apply, I change some variable on that instance. Someone else goes, doesn't see that, doesn't pull my changes, they do that. Terraform's gonna error out. And we can determine in that simple scenario what Terraform sees and what's failing. But once you add complexity, you're like your confidence is shot, right? Your realization, the real world is no longer something you're confident in. You're confident in your intent, but you're not there in your realization. So Terraform offers this really awesome feature called remote state. This is a configuration that is in literally every module I do in the world. There's a little backend feature here where it says S3. There's multiple backends. You can do console, GCS, which is Google's terrible storage thing. I have a lot of opinions about Google. We'll talk about this later. I can't actually remember all the backends. There's a bunch of them. Console is the one that HashiCorp really wants you to buy into, of course, because it's HashiCorp console. I use S3 because, first of all, it's dead simple. Everybody has an S3 bucket. I can also get extremely specific about policies around this, and I'll explain how that's going to happen in a minute. But then you can see here, like I'm encrypting it by default, and I have my own KMS key ID that I can attach. It's gonna encrypt that state in S3, which is also very important. And then I use DynamoDB as a locking mechanism because S3 does not have any ability to lock files. And what this offers me is that if I hit plan and apply on some changes locally, and another one of my team members does as well, whoever gets the lock first wins. and they're gonna encounter error if they don't have the lock. And that's some way of like ensuring some confidence in the changes you're gonna make, right? And we'll talk a little bit more about this in a minute and why this is really vital. But I just want to this is super important. Please use remote state in Terraform.
So the first scenario is the last.
Say that again.
The first scenario where people are just randomly moving applies, it's the last.
If the lock isn't there, yeah. So it's whoever's got the lock, but then if you keep going, it's gonna you're gonna break after the first lock. Yeah, it's all gonna be right. Last apply wins, exactly. Well, in some cases, resources require creating a new resource, and if you're not defensive against that, you're gonna just delete your instance and bring up a new one with your changes. So there's a lifecycle config on most most AWS resources where it will bring up the new resource first and then remove the old one. But that's not default, which is another defensive Terraform thing. I don't even have that in here, but that's a good point. Like lifecycle makes last apply win, yeah. All right, so again, no one talks about remote state. I found maybe 6 blog posts on remote state and how to do this properly. One of them was really good and explained how to do all of this. So you need a bucket. You need a bucket policy because you don't want the public reading your state files. Because if you don't know this, we should talk about this as well. Terraform does not have a sensitivity feature. It will put your secrets in the state file. It does not care about your security. It will just drop keys right into it. And that's only if you specify them or you have something that's producing encryption or credentials. But remember, your state file is not secure. So you need a bucket policy because you don't want it to be public. I highly recommend use like a KMS key if you use an S3. Google has their KMS set up as well. We use Dynamo because S3 doesn't do locking, but like Console does locking. Console also does encryption. If you're using S3 or AWS, you should have a role for literally everything that's locked down to just that specific thing. We also created, Heptio, we created a group that I can join and get access to that role. So there's there's a lot of things to do this properly, but no one talks about it, and that's one of the reasons why I wanted to do this talk. So, and then you need a way to manage all this, right? Because you don't want to go build an infrastructure and set up all your infrastructure by clicking in the console and never being able to repeat it again, right? I want to be able to manage this bucket and this policy and this role just the same way I do my infrastructure. But there's a caveat to that. Managing remote state is painful. The reason being is because Terraform does not allow you, it's not entirely true. It does, you should never do it. If you, let's say we write a Terraform module to build a remote state, right? We build a bucket, a role, and a policy. Once I apply that, there's a state file on my disk, okay? There is a way to move that state to the remote state I just built. But now you have what we commonly refer to as a chicken and egg problem. If you want to manage that again, it can't, if you change that config, it can't read its remote state to get its current state to do this again. So managing remote state is painful. It's very painful. I don't even know what my decent answer is. Sorry, I don't have my notes. Okay, we'll talk about that in a second. So the way we do this, and I'll explain how Heptio does this, and again, I'm just trying to find a way to manage these things, is we created a module called ecosystems. And an ecosystem, and we're going to talk more about this in a minute, an ecosystem is literally just an S3 bucket. It's a GitHub repo, and all the policies and roles and Dynamo tables and all that stuff you need for a remote state. And once you're handed an ecosystem, now you can do Terraform in a secure, remote way and share it across teams. So like we have multiple ecosystems. I think we're up to like 9 or 10. And the way we're kind of doing it is, I'll talk more about that in a second. It's not that important right now. So if you build your remote state, and I'm actually hoping to release some of this open source. It's just not there yet. But just do it locally, save it in a Git repo, put it aside. There's not going to be any creds in that if you're doing S3 and Dynamo. If you're going to do something else, I can't guarantee that. But you can just save that in a repo, build up your remote state there, and then go manage your infrastructure over here with remote state. Highly, super important that you separate those two because of the chicken egg problem. Does that make sense? I'm kind of rambling a bit. I'm sorry. I don't have access to my notes. Cool. So,
What?
oh, sorry. So again, this is where remote state is it's still a problem, right? And Terraform in general is this problem. And so I'm going to talk about defensive ways to handle what happens if Terraform errors. So more than likely, all of us have read a blog post. There's a couple very popular ones about people putting like their entire dev environment in a single Terraform module. Like, oh, we're going to boot up 3 to 4 instances in this thing. We're going to attach EBS volumes to it. It's going to all this complexity. And it's so simple. We put it in this one plan and apply run. Okay. What happens if an instance fails to come up in that run, right? So none of those blog posts talk about this. Some of them do. Some of them have like written blog posts after when they've broken their entire dev or production environment. But if Terraform is going to bring up 3 instances in 3 EBS, let's say the 3rd instance fails out. Terraform fails fast. It does not have any way of reconciling what it's already done versus what it wants to do versus your intent. It doesn't, like, it just stops. So now, again, we lose our confidence in being able to run this system again. Now, in a simple system, simple like module or resource, we just apply again and it'll catch back up. We fix the error and it'll catch back up. It happens, but if this is production and it fails in the middle of something, and well, if you don't use life cycle management either, you're also screwed. But you now have lost all confidence to like approach your production infrastructure. So we really need to think about how can we keep Terraform from failing on our like deployments. How do we manage Terraform in a situation where it touches the smallest entity possible, right? Not the smallest entity, I guess. It's, you know, how can we cut it up into logical wholes? So, yeah, logical entities. Sweet, I know my slides. All right, yeah, so I'm going to explain a little bit more about what I mean by this. But let's say we have a Postgres cluster. Postgres, you know, like if you're going to do synchronous, you want to have 3 Postgres nodes, right? I want to be able to manage that cluster in a way that's reliable and resilient and doesn't go down. You know, I don't want to be online at 3 a.m. to manage my Postgres clusters. And I'm sorry, if you want to be, just don't do it. But so what I want to do is if I'm going to do Terraform the way I consider doing it, the defensive Terraform way, I'm going to put each Postgres node in its own Terraform module. So I can manage each one individually. That means I'm going to have, in one module, I'm going to have an instance of volume, maybe some security groups, whatever. And I'll do that 3 times. And that way I can manage one without impacting these other 2. And Postgres, if you're a Postgres lover like I am, it can handle this situation really well. But it's true for Kafka. It's true for your front end, your apps, whatever. Break them up into logical entities. Don't try to just throw everything into one state file because you're going to have a lot of problems. It's going to be scary. This means demo. So let me show you. Not big enough? Let me go bigger. All right, so I created a little demo ecosystem because I don't want to leak all the shit at Heptio. But let me show you how this is set up. Okay, from there. So I'm going to show you how we defensively use Terraform. I was actually talking, I don't remember your name. Josh. I was talking to Josh a little bit earlier, so I'm going to talk a little bit about TFRs just in a minute. But so if you think about your infrastructure, well, in an opinionated way like I do, I think about my infrastructure in layers. My most important, my most global piece is my network, right? So in Amazon, you got to bring up a VPC. If you're not using a VPC, well, we have other things to talk about, but use VPC. So I call that stage 0 or ring 0 on a computer, right? I'm just using boot stages at this point. But so, and then let's say we have like a Kubernetes cluster, right? That's more global, or Kafka clusters are generally environment global. I'll put those in like stage 1 because those rely on stage 2 to be there. Stage 1, I'm trying to explain what this is. Stage 2, let's say we have an application that needs a database. That's kind of a supporting infrastructure for an application. we put that at stage 2, and then stage 3 is where the application, and I also say this because most people don't believe me, but I want to do my orchestration after my infrastructure. So I want to boot all my Legos, find out what is in front of me, and then connect them all before I start standing up and start building before I know what I have. So I put in stage 3, application orchestration. That's kind of beside the point, but I'm just explaining what you're seeing there. So here's where we're going to talk about logical entities. Now, this is a quick little demo. I just chose 3 things that all depend on each other in some way. We have a public network where we automatically assign IP addresses, and then we have a private network that we create, entirely different VPC that we peer these 2 together. And in the private one, in the data, what I call the data network, is where we put all of our databases. So we need a VPN to get to those, or some type of Bastion host. Don't use Bastion, but VPNs are better. So this is what I'm going to lay out here. So we're going to create a VPC in 000 there, and in 005, the data network, we're going to create another VPC, and then I'm going to show you how we connect them together. Now, each one of these is a Terraform module. So let's go into the main network real quick. And there's a couple of simple files in here. Hopefully I scrubbed all the variables. I'm pretty sure I did. All right, so let's show this again. So again, we have our main, our variables, and our outputs. I'll explain providers in a second. That actually should be a symlink. I just broke it. So we have our main, which is going to use, actually I'm going to do vi because I don't want all my nvim stuff to come up. It's all black and you won't see it. So this is just a VPC module we have. We store them in S3 and version them that way, but besides that, we'll talk about providers again in a second. But this is just a standard VPC we're going to create. We're going to create 3 subnets. I'm not actually going to create this and run this because it will break. But I dummified all the variables. But so this is just kind of a standard way you might see Terraform, right? A module there is just a collection of Terraform behind it that we've put this nice, pretty interface on. And I can show you what that looks like in a minute. But all we're doing here is create a VPC with a couple subnets and some basic networking stuff you want in Amazon, right? And it's the same with, where's our data network? And with this one, another VPC. Notice we're doing a different account. Again, we'll talk about providers in a second, but we're just going to create another VPC, right? So we broke up those 2 things. Where's, oh, 7, sorry. Let me show you what you can do with Terraform that I've not seen a blog post mention this. You can use Terraform state as a resource itself. So we talked about our main network. I don't know if I can highlight this. This is going to look really, whoops. It's going to look really bad, isn't it? Does that make it any easier to read? No. No. All right. So I'm talking about that piece now.
I could have sugar-coated it, but I said.
What's that?
I said I could have sugar-coated it.
Oh yeah, no, please. So I'm gonna point. Sorry,
Josh, is there a way he'll just eat these legs?
These legs?
Yeah. Don't know.
Oh.
Keep going. We're gonna.
Yeah. Okay. Sorry, I didn't know what would be the best here. I mean, I could just do this, I guess.
Maybe increase the size.
Yeah.
Okay. So that data Terraform remote state, what we're actually doing there is we're going out to S3, grabbing that path. So alpha US West 2, stage 0, our main network, and our TF state file. We're going and bringing that into our module as a dependency. And this is why I say break it up into logical entities, because I don't need to put all of this in the same state file. I can create all these little pieces and connect them together. So I'm showing that, but I'm going to go back real quick to here, show you how this is all done. So let's go back and forth on size.
There we go.
Sweet.
Very good.
Is that better?
Yeah.
Sweet. Okay. So again, here's our remote state. Now here's what I love about this setup, right? And this is why I like S3. See that key line there? I should probably turn on. I don't know if I can do that really fast. Okay, thanks, Vi. There we go. I'm using Vi. I haven't used Vi in a while. I use Vin normally. But So line 5 there, that is a full path in an S3 bucket where we're storing our state for our main network. This is the main configuration in this Terraform module. What this allows me to do is I can attach policies to every line there. So let's say I have a network engineer, for example. Most of us don't have network engineers anymore. I don't know if it's kind of a rare commodity these days. But I can actually give him just permissions to stage 0 there. And he has access just to my network. He doesn't need to work on my database servers in stage 2 and stuff. So this is why I like S3 for this stuff. So I can put policies all the way down this path and lock it down, right? So again, remote state configuration. This is where this module is going to store its TF state and that whole path there in an S3 bucket. It's not actually called S3 bucket. If you don't know, S3 buckets are global. So that would never work. But it's just an example. So this is where my state's going to be stored. I'm using Dynamo for locks, and my KMS key are in there. I just wiped out. So that's what I want to show you. I'll show you the result of this. So if you haven't looked at a Terraform state file before, this is one. Okay. The first thing you're going to see on a remote state Terraform state file is the config. This is how it knows when it runs the Terraform command where to put its work. So that little backend thing is always at the top. Not sure that they actually sort the JSON, but I've always found it at the top. So I don't know what the hash stands for. But here's what's really cool about this is that this little module section here, normally this would be filled with your instance IDs, your keys, your EBS volume IDs, whatever you're doing, or any Google properties or any resource would normally be contained down in that. But with remote state, we can check this in and recreate it anytime. So we don't ever have to worry about leaking secrets in a Git repo by using this method, which I think is very key. And by the way, if you're not using Git to manage Terraform, let's talk. Or source control in general, I guess, but I like Git. So
is there a benefit to checking in the .terraform directory?
The benefit is you can see if anybody's mucking with it.
Like editing the Terraform directory?
Yes. So that state file will change if nope, sorry. If someone changes that key by accident, that state file will change, and we can see that that's happening. So it's a great, it's kind of like a canary in some ways. And since it's easily reproducible, I mean, I can wipe that .terraform file, run terraform init again, and it'll reproduce it.
Yeah, that's the reason why I don't have it in my Git ignore. So I never put in the .terraform. I mean, I'm using remote states, but
so we always do a git ignore on plugins and modules because you don't want plugins are just Go binaries. So like we have. Yeah, you look how many directories I have. That's pretty. I'll explain why that is in a second. No, I don't have one in this. Okay, but yeah, you can do git ignore like // plugins .terraform/plugins. So we don't check those in because we always want the latest version. But the TF state file I found is just great for recognizing, oh shit, I broke. I changed something because once. Let's go back to this for a second. Once this state is at that path, you want to treat it like gold, right? I mean, it's encrypted, it's on S3, but this is where the realization of your infrastructure now is. And so if you mess with that S3 path, or you mess with that terraform.tf state file in S3, you lost all confidence again. You're back to, I have this intent, but it's not realized. So for us, it's just a really good way to do it. It's also a great way to see if someone messes up and doesn't do their resources properly, because it is possible to get around this. And you can see what happens. It's just, it's just a good canary. Yeah, so there's and let me do that. I don't know what you can see because I have this little Google Hangout sharing thing. Yeah, so there's the modules and plugins directory. Really, they're here. So you can see this is Mac, and that's like a little Go binary that runs in AWS resources. And so all Terraform is built this way. All plugins are a separate Go binary. There's no there's no way to get it into the main Terraform command, and I can't think of the programming term for linking those. But so basically, Terraform just calls out to these providers. It's very detached, which is actually kind of nice. And same with modules. I think modules, this is where it pulls in my VPC. Yeah, but it's like static linking, I guess is what I'm thinking of. Maybe that's what it, like Nginx for the longest time, everybody complained because you couldn't link in middleware or different modules in Nginx. There's a phrase that people kept using that I've drawn a blank on. What's that?
Shared library? Shared
libraries, that's what I'm thinking of. Yeah, so it's not a shared library. It's just they call out to it. So I don't, because I've not actually run this. So my VPC module is not there. I'll show it to you guys in a second though. What else? Okay, so we covered that. Let's go to our, where we use this stuff now. Okay. So let's look at this first. So again, oh, and there's my AMS key. It's locked down, don't worry. I didn't clear this one. So this has its own path as well. So the peering itself has its own state. Remember, we talk about orchestration that I want to do it after. So that's why I separate out these three. Can't see it, so I'm going to do that because I'm assuming you guys can. So I build my one network, I build my second network, and then I connect them together in my third module, right? That's how I think defensive Terraform should be set up. Because I can go change my main network, and then I'll run my peering, my 007 there, and it'll get updated. If I wanted to go in, if this were all in one system, and I wanted to go and change my data network, I'm actually running Terraform over my other network. Even though it's not going to see the changes, if somebody has changed something there, I run the risk of it deleting my VPC, bringing up a new one because something changed. So I'm reducing my risk by breaking these up, right?
On that note, would you always recommend having setting up separate modules for every single microservice or application or whatever you're standing up, so that you're only affecting that one tier of things?
One tier of things, yeah.
Segregating.
That's the logical entities, yeah. Like you're bringing it into like logical little pieces.
Yeah.
So, you know, an instance might have an EBS volume. I'm not going to put each one, like I'm not going to put the instance here and the EBS volume here.
Right.
I'm going to put them together and the attachment piece here. And I can manage that in isolation from any other.
But you can share ALBs or something like that.
Yeah, exactly. And then I can do that in a module later and just pull in the state so it knows what instances to run. So here, I'm pulling in my main network, I'm pulling in my data network, and let me show you how we use them. Make sure this is that big enough? Okay. So then I'm going to point, sorry, online. So this is, you can see here on, let me set numbers again, sorry. I don't use this terminal or Vi, so this is. So on line 26 there, you can see we're pulling in the outputs of our main network. So the output is the main network VPC ID. I specify that output. Terraform saves outputs in the state file. That's why declaring outputs is very important, because if you declare your outputs after you've applied your state, you have to reapply it so that it can now fill your state file.
So it's really just like CloudFormation export and import. Right?
Essentially,
you do it across stacks.
Essentially.
Very similar.
Yep, very similar idea. And so we're pulling in these two variables. We're pulling our main network, data network, and then I'll show you providers here in a second. That's at line 28. And we're creating a VPC peer between the two. And I can do this again in isolation without impacting my actual VPC. That's literally just a VPC ID. It's nothing else. I'm not actually forcing Terraform to go out and do a bunch of work to figure it out and bring it back. It's just saved it in a JSON file and I'm pulling it in as a dependency. I think it's the same thing down here. This is some of our routing. Whoops. Oh, what the heck is that? I don't know how to do that with. Yeah, so again, there are route tables. We're pulling those in. We're grabbing our CIDR block from them, our peering connection ID, and well, yeah, that's the resource created above it. And we don't have, again, we don't have to do all this in one state file. This is actually going across 3 state files now. So that is, in my unprofessional, maybe opinion, the best way to use Terraform. This is how you do not end up with your dev network just completely shit on. You know, or at 3 a.m. you need to fix something and you accidentally blow up prod because, well, maybe you chose an instance type that you don't have your limits boosted on, right? So AWS starts out with instance type limits. If you've maxed out your limits and you go to run Terraform, it's now your whole production is in some type of flux until you get AWS to increase your limits, right? We don't want to be in that situation. And this way, we can work in isolation like that, fix these problems without impacting everything. So that's that layout. Let's talk about providers real quick. Vi, there we go. Oh. It still has my accounts. What the heck? All right, let me go to my personal, which won't matter. So we're getting to the point where we're going to give engineers each an ecosystem. So they can just use Terraform at piece. This is probably going to have an ID in it. So do that real quick, even though someone could screenshot that. Anyways, and I don't care about my accounts. I can easily delete it. So with remote state, you have an AWS provider that you need to talk with your remote state, right? So this is a kind of a crazy feature of Terraform, is that it always relies on the default AWS provider to find its remote state. So if your remote state backend is S3, it's looking for that provider, right? And the top provider there is what everybody sees, right? When they do AWS, it's just a standard provider. Well, I don't want to put my infrastructure in the same account that my remote state is. That's just my restriction. It doesn't have to be your restriction, but we put everybody into their own AWS account. So in my AWS account, which is the second AWS provider, is where I want to actually put all of my Terraform resources. So what I can do here, and again, I need numbers, is on line 16, I can give an alias to this provider, right? So now I can reference that in all my Terraform. Maybe. Oh, I'm already in that. Go here. Let's not do that one. I guess you can see our bucket, but it's not public. So, sorry guys, I thought I scrubbed this better. Anyways, there we go. So you can see how I'm passing providers to this module. I'm now, everything that runs in that module is going to see AWS and be pointed to that other provider. That way I can use multiple accounts. In some of my ecosystems, I have 12 accounts because I'm like taking a legacy network, connecting it to my new network. I'm grabbing like an RDS network that we created, bringing that in so I can put a VPN to connect to all those. So you can do as many providers as you want and pass them in as modules. But it's also true on every resource. Let me go back to my...
On that note,
yeah.
Connect up multiple cloud providers that way?
Yep. Yeah, I go across Google, GitHub, Vault. So because you can do Vault providers as well. So our provider, well, so in this provider file, the way this is laid out, let me show you this layout here real quick. Yeah, that's okay. So we put our providers up at the environment level, and those providers are the least privileged, meaning that you need at least access to these. Vault might get more specific, and we might put it in a provider file down in a module because we don't want to give everybody access to all of Vault. And these providers you need access to, right? Like these are the big ones. So we put our least privilege, I'm saying that backwards now. Least privilege, that's right. So you need that to even survive. Vault, we don't want to give everybody access, so we might stuff that in a provider later.
There's more
further
access
down.
to get the vault.
Right, yeah. So again, hopefully, yeah, this is the one I actually scrubbed. So there you can see like account 001, account 002, right? Don't worry, our security is good, so I'm not actually that worried about it. I just was doing it to be nice to my coworkers. And you can see we're providing and passing in there, but I want to show you this one. So look at the very bottom there, how we're doing the route tables. That's where we're passing in provider. Again, I need some numbers. So line 55 there. So every resource has provider as a global config. So you can pass in any alias provider to it, and it will just treat it as whatever the base provider is. So using this functionality has really allowed us to expand. I mean, like, again, we have, I think it's 44 AWS accounts at Heptio. We have 40, no, we have 32 engineers. I don't even know anymore. It just goes to bed. But we give every engineer an account so they can do all these things. We have shared accounts, dev accounts, all these different things. So this allows us to really split out and really focus. The other cool thing about providers, where am I at? Is I can do set number, line 20 here, okay? I can force that provider to an account. So this is another way of defensive Terraform. I can ensure that nothing gets run with that role that I'm assuming there in 22 on any other account except that ID. So just another great way to make sure that I'm not like writing in my root state account. You know, we put all of our remote state in our main account. So I don't want to put infrastructure there. I never want infrastructure in my main account. So I can just limit all my accounts to this. Even my remote state one, I have limited as well. So it's only going to assume that role and only run in this account. If not, it's going to bail and Terraform's going to say I don't have permission to do anything. So again, more ways to just be defensive about Terraform. I don't think I was going to, I wasn't planning to talk about, but I'm going to talk about this real quick, is variables for you. So I used to work at Simple, and we had this thing called CloudBank, and it's a piece of work, but it's this Python wrapper around CloudFormation. And what we would do is we could create a Python class for a resource. So like if I want to stand up a Postgres server, I create a new class and I pull in all the different pieces from CloudFormation to make it. The problem is that all the variables are local to that class and sitting in that class, and it made it really difficult to understand how everything works across the infrastructure. Especially being an infrastructure engineer, I need to know where I can get data from. So what we ended up doing, in some cases, is we would do these weird things where we'd go and pull data from way over here using like this really weird event system we built, try to pull, because it was non-ordered. So we had to go over here, pull from this class. We created our own dependency tree just to get variables. So I knew that coming to Heptio, I would never do this again in my life. So we force all of the variables, all the defined variables, up to the environment level. So my environment here is called Alpha US West 2. You can see I'm in that directory. I have this TF-vars file. I'm pretty sure this is scrubbed, yeah. So you can see my main network module that we've been talking about. Here's where I define all the variables that I'm going to use as inputs. And then what this allows me to do is use these really easily, because they're getting passed to every module. When I run Terraform plan, I'm passing in a TF-vars file, because you can do that on the command line. So what we can do, so you can see like my ecosystem name up there, my environment zone, all those things, I just put those as variables on any module, and I can automatically pull in all this context without having to understand the entire tree, right? So another way we enforce this is we never put defaults here. I want every variable file in my modules to look like this, because it forces me to put them up top.
But you do have to still have them referenced there, correct? So that model
Yep.
can pull them in.
Yeah.
That's the thing that It annoys me. I get that it has to happen, but it just seems like
explicit versus
Right,
implicit.
right.
This is the interface. This is like a function, right?
Right.
This is the arguments to my function. And now I can explicitly say, this is what I need in order to do my work. And if you don't give it to me, I'm going to bail. Again, defensive Terraform. So that's my answer to you're talking about like multiple var files. I have these like really terrible. I'm working on a I'm working on a command line client for this whole setup. Like when we have plan, you can actually you can't really see it, but well, I can at least. 77 there, kind of down, but that's our var file. We're pulling it from the environment way up top, put it in, and I don't want people running Terraform directly. I want to create a workflow for us. So that's how we do that. We also automatically create a plan file, just so that we always apply what we plan. I don't know how to make this, get this up higher so you guys can see it here. I guess I could do that. So yeah, so like that's my plan command, right? And I don't want input. I don't want people touching my shit. So like I don't want input. I don't want even an accident of input. So I get very opinionated about how I want my Terraform run, and then I have this apply that automatically looks for dated plans because I just do a date down to the second with a plan name, and I run it that way. So you can see. Sorry. Here's my apply command. So it's just running the plan, input false. Yeah, so that's how we do it. That's, I believe, whoa, where'd my browser go?
Can I ask you how you manage your, not state, but where things are at? So I send the command and say, make these resources. How do I check to see those resources have finished or get something back? How are you doing that?
Say that again, sorry.
So you send Terraform is essentially an API command to Amazon, right? Say make these resources for me. How do you know when that's complete? Like how do you check status of like you want to run something in the box once it comes up and you say I'm good now? And
how you verify it? Yeah, we don't have a good way for that yet. So the way we're doing orchestration is kind of manual right now. Yeah. We just got our 4th team member last week. And I was there since April, but we only have had more people on the team for a month and a half now. So this isn't actually fully automated yet. It's built, and that's why there's all those directories, because it's built to run on Jenkins. Yeah. I know Jenkins, whatever, but it's built to be like a machine can just simply take a directory and just go through and iterate through these things. As far as orchestration, some of that, I mean, Terraform has a lot of providers. So one thing we've been doing, we did this once and we'll never do it again, but we actually use 1Password command line to inject a credential. So you can do crazy stuff with Terraform. So I think we probably do more like just checking in Terraform with local scripts or something like that. So not the best answer, but
we have something that Bright Brain helped us make back when we set this up initially, but essentially values are sitting in console. So like 4 different states of something. We check the states of those, and then we have a case in the declarative pipeline that says if you see this state, you're good. You want to do this and so on. So because there's not like a CloudFormation API call that you can say where am I at with this or what's going on. Right. It's not the same thing. Right? Yeah. Not baked.
It's not well baked. I mean, I know
that piece I feel like is lacking quite a bit. But that's the nature of a third party. Like I get it.
Yeah.
You're not tied in.
Right. One of the things we're also looking at is using a lot more SQS and SNS topics to do things, to shift the data around and know when things are running. Like we're currently hooking up SQS and SNS to spit out this plan command is eventually going to spin up a topic to shove the plan output into a Slack. So we have context of who's running what. And it's useless data, so that's why we're putting it in Slack. Like we can just put it there. We don't
need to get it out. You can.
Yeah, we don't try to put like statement of record in Slack. It's all ephemeral conversation. So plan, that information is not useful beyond 5 minutes. Yeah. So, but we can sit there and look and get context of what's happening. Same with applies. But yeah, there's not a lot of great ways to communicate about these things right now, especially in an automated way, like communicating between resources. But that's another reason I would say another argument for moving your orchestration to another module is that you stand up all these things, and then it's going to require those dependencies in place before it can be. You know, that network peering won't work if that output doesn't exist. So you could run it, and it would just fail because it's like I don't have a VPC ID. You know, those types of ideas. So
It's tied together essentially does all of it for you.
Yep.
You're just missing runtime states or something, or post runtime.
Yeah, and Terraform. I mean, like in the state of like an instance in a TBS volume,
Yeah.
Terraform's going to be really good about that. Especially this is not in my talk or plans, but a lot of resources like security groups in AWS instances, they have a way of configuring a volume within that resource, or a security group. Like a security group will have the rules you can put right in the resource. What you should do instead is create your security group and then create new resources for your rules. Because there's actually a resource just for a security group rule, and that way you can go change this, and it won't mess with everything else.
Won't recreate it.
Right. It only works on that line of that security group. Whereas the other way, if you ever want to break out of that, you have a lot of problems because all of your state is now connected, and all of your targets are now connected. So I don't know why I can't get back to my slides, and I.
Sorry for such a
No, that's fine. I was just maybe.
Minimized, because minimized and you don't. I blame the neck bar.
Yes, I'm already blaming that right now as I try to. Oh, it's right here.
Far right next.
Yeah. So wrapping up, like I hope that's some ways to be defensive when you're using Terraform. Think of your SREs when you're doing your infrastructure. If you're not an SRE, if you're going to build something, build it in pieces, put it together later on, so that we all can come in and help you and not break up all of your crap. So, there's any more questions? Yeah.
So our environment is largely split up. So the one thing I'm curious about is how you handle rollbacks. So like, for example, our officer script splits out the CF and put that out. That would just create for everyone in but that was just so there's been times when obviously so it's nice
Oh wow.
nice to jump back in time like that. So I'm just curious how you if you
Yeah, so I have two answers for you. One is we use versioning on our S3 buckets so we can always get previous state files. That would be one way I would think, similar to what you're doing with the Git repo. But I also have philosophy you only roll forward, you never roll back, which I know doesn't work in all scenarios. But I try to enforce that in every place I go, because rolling back to a previous state is really hard in complex systems. So even in databases, like someone makes a DDL change, now roll it forward, let's fix it. I'd rather take the incident than try to get everything back on the state that we don't want to be, and we're going to do it all again anyways. But yeah, I guess in that scenario, probably versioning on the buckets would probably be the best way to get back to that. Now, I'm actually interested in how Terraform would handle that.
Yeah, I was just gonna ask that.
It probably would handle it fine, though I think I'd have to look, but I can't remember if it stores the serial number in its local that matches the serial number in S3, which might be your problem. You'd probably have to start piecing together state files at that point, which there are lots of blog posts on how to do that because of not being defensive about their Terraform. It's just JSON, so you can figure out the spec pretty simple. So I think that's probably the best answer I have for you. But,
it's not often, but as you have.
Yeah, when you have to. Yeah, I would probably rely on versioning and then piecing together state files, I think. Well, actually, I would just force everybody. I would rather take the outage and roll forward than. I don't always have that choice, granted, but yeah, rolling back is terrible. So.
Correct. So essentially, it'd just be like going back and reapplying. You
you want your state file to be the same, because otherwise, if you go back to state file and all that stuff isn't there anymore. You could reapply this Terraform to its existing state file and take it back.
Yeah. Yeah. Yeah, and that's, you know, and then that's a perfect scenario where no one's touched anything else either as well. That would be another problem there. Yeah, but that's always going to be a problem if you're touching anything outside of Terraform or even CloudFormation. Well, you already just lost all you've got, so don't do that. Any other questions?
We're just gonna be hanging around a little bit.
Yeah.
We gotta have about like a half an hour probably, and Josh will be gonna hang out. Yeah. So before Josh takes us all out.
Was that a good length of the talk?
That was awesome.
Perfect.
Everyone, let's back up. I'm going to work tomorrow and be doing it all. Let's just watch this video and like let's redo a bunch of stuff.
Probably not the right way to convince them.
Yeah, right. Yeah.
People are just as complex as
How
Terraform.
much are you per hour? That was awesome. Thank you for that.
Awesome.
So we are doing some shifting for next month, so we're not 100% sure what it's going to be going for next month, but there will be something for next month in November as well. December we take over for Christmas, etc. So stay tuned for what's coming up. We'll be announcing it hopefully in the next week. One more mention: StockX, the company I work for now, is also a sponsor. So we do high class kind of a secondary market. So we're like a respectful eBay. So ask me if you have any other questions, and like, what are you guys doing? Why are you doing it? What's this whole weird thing going on in Detroit, etc. Would love to talk about it, and I think we're gonna have you back next year. See the evolution of this.
Okay,
and
yeah.
talk about other things as well.
Yeah.
Like definitely, maybe even like talk that you're in Lansing, right?
Yep.
So not too far away. So
Not far away.
definitely thank you for coming. Thank you to all of you for coming, and we have about a half an hour. So hang out, get some more food. There's plenty of Pizza House left, and have a great night.
One last
Thanks,
thing I
guys.
didn't say is we're hiring, so I have to say it.
Who is
I'm
it?
like it's on contract, I guess. So
Very cool. Thanks, guys.
thanks.